Hi guys, welcome back to the class. In yesterday's class, what did we discuss about? FLSM, VLSM. What is FLSM? Fixed length subnet masking. What is VLSM? Variable length subnet masking. Now, according to FLSM, we have to use the same subnet mask. If you're doing subnetting, we have to use the same subnet mask for all the networks or all the teams. Yesterday we saw IT team, HR team, sales team. For all the three teams or for all the three networks, we are using the same subnet mask according to FLSM. According to VLSM, we can vary the subnet mask value. Correct? Then we saw what is TCP IP model. Yeah. So what is TCP IP model? US Department of Defense in 1970s. Good. So what is OSI model? So tell this also. So OSI was basically introduced to standardize the communication between internet devices. Okay, this is important. Then how many layers are there? There are 7 layers in OSI model. Correct? And we saw the explanation for all the 7 layers yesterday. Correct? Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Okay, so today we'll discuss about TCP and UDP protocols. Okay, so first thing, note down that total number of ports available are 65535. In that, 0 to 1023 are reserved for TCP IP applications. Note on the first point. Okay, note on these 2 points. TCP protocol number is 6, UDP protocol number is 17. So we'll start off with the first protocol, that is TCP. TCP stands for Transmission Control Protocol. Is a transport protocol that is used on top of IP to ensure reliable transmission of packets. So TCP is a layer 4 protocol. Transport protocol means layer 4 protocol in the OSI model. Okay, to ensure reliable transmission, which means there will be no data loss. Why will there be no data loss? Because there is something known as acknowledgement. Okay, we will see what acknowledgement is as we go through the slides. Then TCP includes mechanism to solve many problems that arise from packet-based messaging, such as lost packets, out-of-order packets, duplicate packets, and corrupted packets. I told you, any error in the packets, any corrupted packets, any missing packets, anything like that can be recovered again. Okay, so this is a sender and this is a receiver. Receiver can request sender to retransmit the same packet again because it has been corrupted or it has been missing or any other problem like that. Since TCP is a protocol used most commonly on top of the IP, the Internet Protocol stacks and sometimes referred to as TCP IP. So in TCP IP model also TCP protocols are used. Okay, note down these points. See this guys, lost packets, this can be recovered. Out of order packets, TCP uses sequence number. It transmits the packet one by one. First packet will be delivered first, second packet will be delivered second, and third packet will be delivered third. Out of order packets will not be there. Okay, and duplicate packets. If there is duplication, the receiver can get to know. Okay, if the sender is retransmitting the same packet again, then receiver can get to know and it can inform the sender. And corrupted packets. I told you if the checksum changes, then there's a corrupted packet. Checksum is a number. Correct? Okay. Done. We'll see the next slide. Okay. UDP. The other protocol we'll be discussing is UDP. So UDP stands for the User Datagram Protocol. Is a lightweight data transport protocol. Why is it called lightweight? We will see in the next slides. We'll see TCP packet and the UDP packet. Then you will understand why we are calling this as a lightweight data packet. UDP provides a mechanism to detect corrupted data packets, but it does not attempt to solve other problems that arise with the packets, such as lost or out of order packets. That's why UDP is sometimes known as Unreliable Data Protocol. This is the actual full form, okay? If they ask you the full form, this is the actual full form, but it is also known as this. Look at this sentence. So, in UDP protocol, you can get to know if the packet is corrupted. Suppose sender and receiver is sending packets. Receiver can get to know if this packet is corrupted, but receiver cannot request the sender to retransmit it, or suppose if this packet is missing, receiver has lost this packet, it cannot ask the sender to retransmit the same packet again. That's the problem. But it has the mechanism to detect if it is corrupted or missing. But there is no option for retransmission. And also, out of order. This can be the second packet. This can be the first packet. This can be the fourth packet. This can be the third packet. There is no guarantee that when you use a UDP protocol, sender will be sending these packets in correct sequential order. But if it is TCP, it will be sent in correct sequential order. First packet will be sent first, second, third, fourth. Okay. UDP is simple but fast, at least in comparison to other protocols that work over IP, which means UDP is faster than TCP. Why? Because TCP, when it sends a packet, it will get an acknowledgement, sends a packet, again gets an acknowledgement to this. Sender will send one packet, receiver will tell, yes, I have received that packet. That is acknowledgement. So it takes time. In UDP, there's no problem for that. There's no acknowledgements. Correct? That's why UDP is faster than TCP. It's often used for time-sensitive applications, where speed is more important than accuracy. Now, the live match is what you see. Correct? It's okay even if you lose some data or even if there is a low quality, but has to be delivered live match. Correct? If the channel is broadcasting a live match, even if the quality reduces a little bit, that's okay. But they have to telecast it live to the audience. Correct? Online guys, any doubts until now about TCP protocol or UDP protocol? See guys, these two questions are important. Protocol number. TCP protocol number is 6, UDP protocol number is 70. They will ask this in the interview. Do you know the protocol number of TCP and UDP? And they will ask this question. Do you know how many total number of ports are available? Okay. And port numbers are present on which layer of OSI model? Yesterday we learned. Come on guys, memorize. Yesterday we discussed about port numbers. Transport layer. So, which layer is it? Yeah, fourth layer. Port numbers are used in fourth layer. IP addresses are used in correct layer 3. MAC addresses are used in data link layer. So how many port numbers are there? That is important. 65535. In that 021023 is reserved for TCP IP applications. Okay, we have something known as DHCP, DNS, HTTP, HTTPS. All these use certain port numbers. So all these services are reserved for certain port numbers. Just a second, I'll show you that. I have this thing. If you want, I'll upload it in the drive. I have the list of protocols and port numbers. You see this port number? Port number 23. Yesterday we discussed about Telnet and SSH. SSH uses port number 22. Telnet uses port number 23. So there is information of so much. If you feel this is too much, I have this too. Not this. Yeah. These are common port numbers. It's 2 pages. You don't have to know all the port numbers. Just for CCNA portion, this is important. SSH, FTP, then DHCP, Where is port number 67, 69? Yeah, 67 and 68, sorry. See? HTTP. As we finish our portions, no, you will get to know more protocols. So for those protocols, if you see the port numbers, enough. And protocol numbers, if it is there, if you see, that is enough. I will tell you the port numbers and protocol numbers when teaching also. But if you want all that in one, one page, then I have this PDF for reference. What's that? What purpose? Port numbers. It's like row numbers. You need number to identify the port. Number under the port. Yeah. What? Number under the ports. Yeah. Each port will have a port number. And these port numbers are logical, not physically present. Okay? See, you need to sort the... See, yesterday I told you about the parcels. Correct? If you receive all the parcels in one door, what will happen? Traffic management will be tough. So you have made 3 doors for each purpose. For Swiggy, 1 door. For Uber Eats, 1 door. For Zomato, 1 door. Correct? That is more organized. So that is how they are organized using port numbers. Explain it like this, why port numbers are made. So on the computer, you might be using 3 applications at once: WhatsApp, Instagram, Facebook. Correct? All 3 data traffic, if you get in one door, what will happen? There can be data corruption. Correct? Data management will not be nice. So each application will use one port number, one door. And guys, we'll see differences between TCP and UDP. Okay? Okay. What is the difference between TCP and UDP? This slide is important. They will ask this in the interview. So TCP is known as connected. UDP we call it as connectionless. Why? Because in TCP, I told you, it's a two-way communication. Sender will send the packet, receiver will give an acknowledgement to it. Then the sender will send the next packet. Again, you will get a acknowledgement. So there is a connection built. But in UDP, this is the sender, this is the receiver. Sender will just keep sending packets, whether or not receiver wants to receive. Receiver, first he will just make a request. I want these informations. And sender will just keep broadcasting all these messages. Broadcast or unicast. Sender will keep sending the packets. Sender will not know if receiver has received it or not. And receiver will not know if sender has sent all the information or not. Okay? That's why connectionless. State memory. So in TCP, you can get to know if there is a 5 MB file and you have sent 3 MB. You can get to know that there is 2 more MB left to send to the sender. Then this is stateless. Why stateless? Because you will not know how much more packets has to be sent. And even receiver, you will not know if complete data delivery has been done. In this case, receiver can get to know that 5 MB file is being sent and 3 MB has been received and 2 more MB has to be received. Okay, then it sends in byte stream, 1 by 1. This is known as packet or datagram. These packets are just being sent to the receiver. Ordered data delivery. I told you, sends in a sequential order: first packet, second packet, third packet. No sequence guaranteed. Can be 1, 2, 3, or it can be 3, 2, 1. Any sequence. It is reliable. Why? Because if any data packet is missed, it can be recovered. This is lossy, because if you lose any data packet, it cannot be recovered. Error free. Error packets are discarded. So if receiver finds any error in this packet, he will just discard it. But in TCP, he will request again and get that packet retransmitted. Handshake is there. We will see what handshake is. There is 3-way handshake, 4-way handshake in TCP. We will see what it is. And there is no handshake in this. Okay. Flow control. So you can control the speed of transmission. In UDP, you cannot control the speed of transmission. If the sender is sending in 10 Mbps and if the receiver can support only 5 Mbps, then it's a receiver's problem. Sender will not slow down. But in TCP, receiver can tell sender to slow down the speed of transmission. Relatively slow, relatively fast, point-to-point connection, supports multicast. Okay, UDP is used when you have to send the same information to more number of people. TCP is used mostly when it is one-to-one connection. Okay, these points are important. So you guys understood these points? Connected, state memory, byte stream, ordered data delivery, reliable, error-free, handshake is present, flow control, relatively slow, used in point-to-point connection. Online guys, any doubts and differences between TCP and UDP? No, sir. Okay, guys, thank you. And this, what is handshake? We will see in the next slide. Online guys, have you installed Cisco Packet Tracer in the PC? I will send our lab instructor's number in the group. If you guys need any help in installation of Cisco Packet Tracer, contact him. Okay. 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 I have pinged this number in the group. If you need any help in installation of Cisco Packet Tracer, ask him. Boys, any of you have enrolled for CCIE? Okay, you got even you then. 1, 2, 3, 4, 5. Okay. CCNB? Wow. Okay. 1, 2, 3. Okay. Okay, now let's see how TCP three-way handshake happens. Okay, before the data transmission, there is a three-way handshake that happens. So send off, okay, we'll send a synchronization packet. Let me explain here. So look at this. Here I have used client and server. Okay, this is the receiver, this is the sender. Receiver first requests for some data. Okay, then sender, he will send a sync packet with an acknowledgement. First, client will request for a synchronization with server. Okay, server will reply back that yes, I'm ready to sync, and it will give an acknowledgement for synchronization packet. And client will send, okay, I'm ready to receive acknowledgement. And then the data transmission begins. Okay, so receiver first sends a packet, synchronization packet. Okay, I need some data to be transmitted. Are you free? Sender will send the packet. In this packet, there is synchronization plus acknowledgement to previous synchronization packet. I am ready to send the data and acknowledgement for this synchronization packet. I have received a packet from you for synchronization to send data packets. Receiver will tell the sender, this acknowledgement is for this synchronization packet. In this acknowledgement packet, what will the receiver tell? Okay, I'm ready to receive it. Okay, and then there will be a connection established. Correct? After this, there will be a connection establishment. Then the sender will start sending data packets. Data packet 1, sequence 1. Receiver will send an acknowledgement packet to this. What will it be? Acknowledgement to data packet 1. Next, data packet 2, sequence number 2. acknowledgement packet. Correct? Now assume this packet is corrupted or this packet has been missed. Okay? Sender will send the data packet 4. Sender will continue. Okay? And receiver will also send an acknowledgement to this. So here there will be a database. Okay? Sender will maintain a record of all the acknowledgements. Acknowledgement 1 received. Acknowledgement 2 received. Acknowledgement 3 not received. Okay? Acknowledgement 4 received. Here data packet 1 received. Data packet 2 received. Data packet 4 received. At some point, receiver will realize that data packet 3 has not yet been received. So what will it do? It will send a retransmit packet. Okay. What will the sender do? Sender will check its database table. Has received acknowledgement 1, which means data packet 1 has been delivered. Acknowledgement 2 has been received, which means data packet 2 has been received. Acknowledgement 3, it's missing. Acknowledgement 4, it's present. So what will the sender do? Sender will generate a data packet 3 again and send it to the receiver. Data packet 3, sequence 3. And then the receiver will send a acknowledgement for. So here data packet 3 and here acknowledgement 3. Understood how TCP works? Packet flow in TCP. First, connection establishment. A synchronization packet will be exchanged. I need this data to be sent. Sender will tell. Sender will inform a synchronization plus an acknowledgement. Sender will inform I am ready to send the data and acknowledge to the synchronization packet whichever receiver has sent. Correct? And what will the receiver tell? It will acknowledge to the synchronization packet. It will inform sender I am ready to receive the data and you can start the transmission. And then the data transmission will begin. Data packet 1, data packet 2, acknowledgement packets, data packet 3 missing, data packet 4 sent, acknowledgement for 4, you got it. Then retransmit data packet 3. Sender will check its database table. Acknowledgement 3 was missing. So what will it do? It will generate a data packet 3 and send it again to the receiver. What will the receiver do? It will acknowledge to the data packet 3. Correct? Now there is data packet 3 and acknowledgement 3. No data loss. Okay? This is the data packet flow in TCP. This is client, this is server. And here I have made it as sender and receiver. This is the client, this is the server. Okay, make a note of this three-way handshake. And now do you want to make a note of this? Yeah? Okay, and then if I zoom out, can you see? First, note down this three-way handshake. Then note down this connection has been established and data packet flowing. Okay, first note down this. No. This happens in TCP only. I'll show you next UDP packet flow so you will understand. No, this is not an important thing. This synchronization packets are important. See, active open means this PC is always ready to receive the data or send the data. Okay. Server is passively open means if there is a request, then there will be data transmission. If there is no request, then there will be no data transmission. But client is actively open. It is always open for receiving data or sending data. Shall I go to the paint? Was it visible or no? Now it's visible, no? When you guys are done with this part, let me know. I'll scroll down. So, guys, why do we basically use this sync acknowledgement? Sync and acknowledgement, basically, why do we use? To establish the connection, correct? Connection has to be established. Once connection is established, then only data packets will start flowing. Okay. You can also say receiver is requesting the sender. Please establish a connection with me. Sender will tell, I have received a acknowledge sender. In this acknowledgement, what will it mention? I have received a request for connection establishment, and I am also ready to establish the connection. And acknowledgement, please establish the connection. So guys, this connection can be established other way around also. Sender can also send one synchronization packet to receiver. I have data to send to you. Please establish the connection. And then receiver can send one sync and acknowledgement packet. Correct? It can happen the other way around also. Just so that you guys know. Receiver can also make the connection establishment request and need some data to be sent. It can send a sync packet. Sender can also send a synchronization packet similar to receiver. I have some data to send to you. Please establish connection. And then receiver will send one synchron acknowledgement packet. Okay. Connection establishment can be initiated by sender or receiver. Both can initiate. When receiver establishes, what will it be? I need some data. Please send the data. When sender establishes, it will be, I have some data to send to you. Please establish the connection. Okay. I'll scroll down. Okay. Now we'll see four-way handshake. Okay. So in four-way handshake, after the data transmission is finished. Okay. So sender will send a finished packet. Data transmission has been finished. Receiver will send an acknowledgement to it. Okay, data transmission has been finished. And receiver will send one more finished packet. Okay, then we are good to end the establishment or connection. And sender will send one acknowledgement to it. Okay, I'm ending the session. Understood four-way handshake? Sender will send the receiver. Data transmission has been finished and we are good to end the connection. And PC2 will send one acknowledgement. Okay, I have received the pin packet from you, acknowledging to it. Receiver will also send one finished packet. Okay, then I have received all the packets. I have received all the data. We are good to end the session. Sender will tell, acknowledging the finished packet, ending the connection. Okay. Online guys, did you understand three-way handshake, four-way handshake, and data packet flow in TCP? Yes, sir. Offline guys, any doubts about three-way handshake, four-way handshake, and packet flow? Sender will not know. Okay. It's the receiver which initiates a retransmit packet. And then sender will check its database. So usually it's the receiver who keeps a track of the database. Data packet 1 received, data packet 2 received, data packet 3 received, 4 received, 5 received. Okay. Suppose if any data packet is missing here, and then it will send a retransmit request to sender. And then sender will check its database table. Okay.
But if packet of data was it has to be published. But the corrupted packet data 3,
you see, until data packet 4 is received, receiver will not know that data packet 3 is missing, no? Once data packet 4 is received, then it will know that data packet 3 is not being received. So before 4, it will still be waiting for 3 only. Yeah, receiver will actually keep a track of these data packets. If receiver misses any data packet, then it will send a retransmit request to sender. And then sender will check its database table. Okay, I have not received acknowledgement 3, which means the request is correct. Then it will retransmit again. Four-way handshake done. Okay, see UDP packet provides. The receiver has sent a request. I need some data from you. And sender just keeps sending the data. No acknowledgement. We don't know if this is data packet 1. This can be 3. This can be 2. When you're watching some videos, live videos, there can be some disturbance, correct? Have you observed that there is some disturbance while watching? That's the problem. Data packet has not been received in sequential order. So if you have high bandwidth, very good internet, then you will not face this issue. High bandwidth, good internet has to be on both the sides, sender and receiver. If anyone faces internet issue, then there will be these kind of problems: disturbances, low quality videos, noise in the videos. So UDP packet was simple. Next, we will see the packets of TCP and UDP. So I'll take down this diagram, then I'll explain you the diagram. Then boys, okay, see this. In TCP header, 16-bit is for source port number. Another 16-bit is for destination port number. And there is sequence number. I told you sequence number 1, 2, 3, 4, 5. So sequence number 1. Okay. And acknowledgement number. If sender is sending some packet, receiver has to send an acknowledgement to it. So whenever sender is sending a packet, there will be sequence number. Correct? Sequence number 1. So this field will be filled that time. It will be, the number will be mentioned, sequence number. Suppose 00001. Just an example. This sequence number is present in the sequence number. Acknowledgement field will be, it will not be filled when you're sending the packet. When you get the acknowledgement to this, that time acknowledgement number same again 00001 will be there. Okay, so sequence number is present in this field. Acknowledgement number is present in this field. When sender is sending a packet, sequence number, this field will be filled and this field will be empty. When receiver is sending an acknowledgement to whatever packet it has received, it will send the acknowledgement number here again 00001 and sequence number will be empty here. Okay, and this, just a second, header length, it is 4 bits. So sequence number is 32 bit, acknowledgement number is 32 bit. Header length actually mentions from where the data actually starts. Okay, how big is the header and from where the data starts, actual data starts. That is header length. That information is present here. Reserved bits, we do not use this. 6 bits is reserved. Okay, we do not use this field. And we call these are known as control flags. Okay, so each field here will be either 0 or 1. It is 1 bit. Okay, urgent bit will be 1. So let me take this example. Sender, receiver. So sender is sending packets. Okay, sender is sending the packets in 10 Mbps speed, but receiver is able to support only 5 Mbps. Okay, so receiver will inform the sender, slow down the speed. You are sending me packets in 10 Mbps speed. So a little bit of data packets will get stacked up here. Receiver will slow down, but during 10 Mbps, whatever packet it has sent, it will get stacked up here. So receiver will slow down. Previously, it was sending for 1 second 1 packet. After receiver has told the sender to slow down, Next, it will start sending the packet. For 5 minutes, it will send one packet. Understood? Because there are packets stacked up here. These packets has to reach the receiver first. And then if it wants, it can pick up the speed again. Correct? This is known as buffer state. So here, the packets are being stacked. Packets are moving slowly. It's not that they've stopped, but they're moving slowly. You can say there's a congestion or a traffic jam. But the traffic is moving slowly. So this is a buffer state. Okay? And assume there is an important packet in this buffer state. So this packet is important. This packet is important. Third packet. And it is in buffer state. First this packet has to be transmitted, then this packet has to be transmitted, then this packet will be transmitted. But we want this packet to be transmitted immediately. So then, here, urgent bit, this field will be 1. Okay? And in urgent pointer, this field, the packet number will be mentioned. Okay? And then, this packet will be immediately sent to the receiver. Understood this part? Next is acknowledgement. So whenever a sender is receiving a acknowledgement packet, here there will be acknowledgement number and this field will be 1. When sender is sending some packet, sequence number will be filled and this field will be 1. It will either be 1 or 0 in this field. Okay? Next is push. So did you guys understand ACK sync? Huh? Okay. So next is push. Okay. Come back to this example. Assume there are a lot of packets in buffer state. And these packets have to go to the receiver. Okay. There's a lot of congestion. So sender will send a push packet. Okay. Sender will send a push packet and immediately all these packets in the buffer state will start moving fast. Will start getting delivered fastly to the receiver. It will be pushed. Okay. So that time, this bit will be on. Okay. And reset. Suppose receiver wants to reset the connection. He wants to re-establish the connection. Receiver. Okay. Maybe the packet flow is not proper. Maybe the TCP connection is not good. He wants a re-establishment. So then receiver can send a re-establishment packet and reset will be 1. Okay. Fill. This will be 1 when they are sending a finished packet. Whenever you're sending a finished packet, this bit will be on. Next is window size. So in one packet, how much amount of data can you transmit? Correct? In one packet, you cannot fill all the data. There will be certain limit how much you can fill. So that is window size. Checksum, I explained you. This is a sequence number. If this changes, then we can get to know that packet has been corrupted. And this urgent pointer, I explained you. Whenever urgent bit is on, we need to mention which packet is important and has to be immediately sent. That information will be present here. This option, any extra information to be provided, you can fill here. And from here, the data starts. Okay. Understood TCP header? Okay. So whenever you're sending a packet, there will be sequence number mentioned here from the sender, and this flag will be on. Then acknowledgement number. Whenever receiver is acknowledging to the synchronization packet or synchronization data packet or the data packet whichever it has received. So that time acknowledgement control flag will be on and acknowledgement number will be mentioned here. Okay. Next is UDP header. Look at the header. What are the informations present here? Only source port, destination port. This is length. What is the header length? From where does the data starts and checksum number. I told you, you can get to know if the data packet is corrupted. That is why checksum number is present. Now do you understand why do we call it a lightweight header or a lightweight packet? There's only these four informations: source port number, destination port number, length, and checksum. That's it. And guys, this sync flag will be also on when you're sending a synchronization packet. This send control flag, it will also be on when you're sending a synchronization packet. Okay. Online guys, any doubts with TCP header and UDP header?
All good, sir.
No, there's no termination. There's no termination. There's only establishment. See, come back here. Receiver will request for data and sender will just send all the data. After sending the last packet, there will be no closure. Just the last packet will be sent and then sender will keep quiet. Yeah, there is no four-way handshake. Suppose 5 packets has to be sent, 5 packets will be sent, and then that's it. Here maybe only 3 packets will reach. That's it. So there is no closure here. That's the problem. This you guys note it down. Done, boys? Okay. Next, let's see characteristics of a router. We had discussed these characteristics in the beginning. Router works on layer 3 and is a network layer device. Router is an intelligent device because it can make its own decisions. It has memory and so it can store data, routing table and ARP table. Correct? Router has per port broadcast domain. Router has per port collision domain. Router uses IP addresses to communicate. Correct? Do you want to make a note of this again? Not required? Okay, next, let's see what are the components in a router. So in a router, there is ROM, which stores the configuration, saved configuration. Okay, so whenever, suppose you restart your PC, you want certain programs to start wherever it is left out, correct? Saved configuration will be loaded from the ROM. Next is RAM, stores running configuration. Now, in this notepad, if I make any changes, I have a new configuration. It is present in the notepad. If I don't save it, this configuration will be gone. It is present in RAM. Suppose if I save it and then open it again after restarting, the configuration opens from the ROM. Saved configuration, running configuration. Next, NVRAM stores startup configuration. So as soon as the PC starts, you want few programs to load and open. Correct? In the ROM, what will happen? It will not automatically open. Suppose you restart the PC and you want certain application to open. When you open that application, and then that application will start from the previously loaded configuration. In NVRAM, as soon as you reboot the system, correct, configurations has to load. Applications have to start. Then there is flash, contains the operating system. Okay. Then there is bootstrap. It checks sequence number. What is the sequence number? We will see in the next slide. Next, we have post. Checks hardware configurations. Okay. Get this done. So let's see the flowchart of a router. First, hardware configuration is checked. Okay. Next, bootstrap. It checks the sequence number 0x2102, 0x2142. Okay. So it basically checks if there is a password before booting the OS. It asks you for the password. If it's asking you for a password, then it is loading this sequence number. If it is not asking you for password, that means if there is no password set, then it is loading with this sequence number. Okay. From Bootstrap, it will start finding the OS. If there is OS present, then it will load the OS. If there is no OS, it will go to flash mode. In the flash mode, it will check if there is any OS stored. If there is any OS stored, it will load the OS. If there is no OS stored, it will go to TFTP mode. I told you, two file transfer protocols, FTP and TFTP. Visa, it will go into TFTP mode. So in TFTP mode, if you have any OS in the external hard drive, you can transfer it to the TFTP mode and you can load the OS. Okay, you can transfer the OS to the router and then load the OS. If you don't have that option too, then it goes into Roman mode. In Roman mode, there is a mini OS. Okay, in your computer, if your Windows doesn't load, it goes into booting mode, correct? A boot OS loads. You guys know that blue color screen flashes and it goes into booting mode. That's a small mini OS. Goes into Roman mode. From the Roman mode, you can load the OS again. Okay. So next, it loads the OS. After loading the OS, it checks the NVRAM. Startup configuration. Okay. After checking the startup configuration, it loads the configuration to the RAM. And then router will start. Okay. Done, guys? Okay. Next, let's see what are the router modes. So router has 5 modes. Okay. First one is user execution mode. Second one is privilege mode. Then you have global configuration mode. Then you have interface configuration mode. And in the last, you have Roman mode. Okay, so what is user execution mode? As soon as the interface up message appears and press enter, the router, it gets into this mode. I'll show you. In the Cisco packet tracer, I'll show you now. Okay. Prompt will pop up. This is called user execution mode. This mode is limited to some monitoring commands. Okay. Next, you have privilege mode. In this mode, if we type enable, we go into privilege mode. As we type enable to user mode, we enter into privilege mode where we can view and change the configuration of a router. Different commands like show running configuration, show IP interface brief, etc. can run on this mode, which are used for troubleshooting purpose. These commands can be used in this mode. What are the commands? We will see later as we configure the router. Okay. You guys want to note on this? Or shall we go to the next slide? You want to note on? We'll go to the next slide. Next, we have global configuration mode. Okay. So in privileged mode, if we type configure terminal, we will come into global configuration mode. As we type configure terminal to user mode, we will enter into global configuration mode. Commands enter in these modes are called global commands. Why? Because if you enter any commands here, it will make changes in the whole router. Okay. So in the router, there are interfaces. Okay. To connect a switch, PC and other things, there are interfaces. Okay. So if you make a global configuration, that will affect to the whole router. If you want configuration only for this interface, then you have to get into interface configuration mode. Okay. In this mode, different configurations like making local database on router by providing username password can set enable and secret passwords too. In interface configuration mode, in this mode, only configuration of interfaces are done. Assigning an IP address to an interface is done. Bringing up the interface are common task done in this mode. Okay. We go to the next slide. Okay, see. Next we have Roman mode. We usually don't make use of this mode in CCNA level. Okay. We can enter in this mode when we interrupt boot process of the router. Generally, we enter this mode while password recovery process or backing up of iOS on the device like TFTP server. It's like BIOS mode on PC. Okay. Done, guys. So this is Cisco packet tracer. Okay. Okay. Click on this network devices. Click on network devices and then you will get a list of routers here. This is a router, this is a switch, and these are other networking devices. We will click on this option. Click on network devices, click on routers. Okay. Then there are various versions of routers. Choose the last one, 2811. Okay. This is a router. Click on this. Go to CLI. Here, always give no. Okay. Or else you have to manually configure all the settings from the starting in the router. Just give no. You see this? What is the first mode? Is it execution mode? Here type enable. Hit enter. You have entered privilege mode. Here type configure terminal. You have entered routers configure mode. Now, let's see how many interfaces are there. If you type EX or EXIT, you will come back to privilege mode. Show IP interface, short form is int. Okay, so you have these many interfaces on the router. Fast Ethernet 0 by 0, fast Ethernet 0 by 1. VLAN you don't see, this VLAN you forget. Not a problem, just see the interfaces. Right now interfaces are important. It has two interfaces. You can just hover your mouse over the router and you will still get these informations. See this? You will get port information. See if IP address is assigned. Come back over here. Do we have IP address assigned to these interfaces? No. Okay. We will try to configure one interface. For configure terminal, there is a shortcut. Okay. For enable also, there is a shortcut. We are here again. Instead of typing enable, just type EN. That is enough. Okay. Here, instead of typing configure terminal, a big word, just type con space T. Okay. You will enter into configure mode. Here, instead of typing interface fast Ethernet 0 by 0, so you have to type this much. Complete one. This is a complete command. Instead of that, there is a short form. Instead of such two big words, just type int, short form for interface F0 by 0. F is the short form for fast Ethernet. Hit enter. You have reached configure interface mode. This is global configuration mode. From global configuration mode, we entered into configure interface mode. Here we will assign an IP address for this interface. How do we assign? Type IP question mark. You have so many options. Just type IP address. Okay. Question mark. It is asking you for an IP address. We will give 192.168.10.10. This is one IP address. IP address. Mention the IP address and then give a question mark. What is it asking? Subnet mask. So we cannot just assign IP address. Every time we assign IP address, we have to give a subnet mask. So here we will give 255.255.255.0 /24. Hit enter. IP address will be taken. By default, interfaces of the router will be down. You have to give this command. No shutdown. For shutdown, there is a short form. And that short form is SH. If you give no SH, do you see this? State to the up, come top. For fast internet 0 by 0, what do you see? IP address unassigned. Port is okay, it's functional. And status is administratively down. I told you. Ports will be down. By default, you have to manually make it up. So for that, what is the command you give? No shutdown. Short form for shutdown is SH. Now come back. Well, you can type exit or you can type EX. For show, short form is show. Show short form is SH. Okay? This is the short form. Show IP interface brief. Instead of typing the complete words, you can type this. SH IP interface BR. Now what do you see? Leave protocol. Just see this. Status. What is the status? Status is up because we entered no shutdown. IP address is 10.10. Method is manual because we manually entered the IP address. Correct? That's all. Fast internet 0 by 0. IP address assigned is 192.168.10.10. Port is functional. This is manual. We manually enter the IP configuration to the interface. Status is up. If you don't give no shutdown, it will be administratively down. We want the interface to work. So you have to enter no shutdown. Here it is no shutdown. In configure interface mode, SH means shutdown. Okay. Here SH means show. Where is it? Yeah, here. Okay. That's all for today, guys. Online guys, any doubts?
No, sir.
Okay, guys. If you guys have no doubts, then we are good to end the class. Offline guys, any doubts? No doubts? Okay, guys. I'll see you guys tomorrow again. Bye bye. And online guys, hold on. Don't leave the meeting. I'll stop the recording. I have to take attendance.
No.